Let f of x equal to cube root of absolute value of x. Determine whether f is odd or even or neither odd or nor even. So justify your answer. So in this question, we have to decide whether it is even or odd. Now, the first thing we check is, okay, it's better you write this way, like if you're checking both, you write f of x and calculate negative f of negative x. So this will be the absolute value of negative x, so it will be cube root of the absolute value of x. And then you can also check this one. I mean, if it is asking all of them like odd or even, you can also check this one, minus f of x. So I generally write 3 of them. Then okay, it becomes minus cube root of x. Now, then we check these two. If they're same, then it means it's even. So they are same. So they are same. We have f of x equal to f of minus x. So you say f is even. Now, if you got even, I mean, no need to look at the oddness, but you can also check. So here, f of x is not equal to minus f of x. Sorry, this is no, this is not true. I mean, you can check it's automatically not, because if it is even, then it has to be, I mean, it cannot be odd, but you can say also, you can compare these two. You can say this f of x for minus x is not equal to this one, is not equal to this one. So you say f is not odd. So this is the justification of our result. This f of x is this, f of minus x is this, and that gives you it's even. Determine the expression of the function. Now, as you see, we have three different behaviors here. One is on this part of the real line, and in this part of the real line, there's another behavior, and then also on this part of the real line. So this is a piecewise defined function, so it has some behavior here, and we want to find the equation of this, but y it will be alone, and then we will find the equation for this y. We'll find this one y equal to what? Now this becomes this is a line, right? This is a line. So what is the equation of this line? So you take, you can take two points here. I'm taking, okay, let's say this 4, and minus 4 and 4 is 1 point, and 3 and minus 3, okay, minus 3 and 3, just for only, I mean, first you write x, yeah, so we have here, now if you are given 2 points, then you can find the slope of this line. So slope will be 4 minus 3 divided by minus 4 minus 3. So it will be 1 over minus 1 here. So it will be minus 1. Now take a point and write the equation. So I'm taking this point and I'm using the slope here. So I will use slope point for y minus 4. No, sorry, this y minus 4 is equal to minus 1 times x minus 4. So this will give us y minus 4 is equal to minus x. Here it will be plus, but with this minus it will be negative again. So we end up with y equal to a negative x line. So this part of the graph now has this equation, y equal to negative x. Now let's check this part of the graph. So we take 2 points here. We can take these 2 points here. It will be 0, 0, and this one will be 1, 1. Okay, one thing, you can also put 0, 0 here. Okay, you can use also this one. But I didn't use 0, 0, but it's okay. Even for this line. But anyway, let's forget it now for now. So let's concentrate on this one. Now the slope here is 1 minus 0 divided by 1 minus 0, and we use this point here to get the point slope form. Y minus y0 is equal to 1 minus, so this is 1, slope times x minus 0, so it will be y equal to x. So we got this one now. This line is y equal to x line. Now for this part, we can say it's a horizontal line, as it's a horizontal line. And so it will be 3, and then we can say it's 3. So we got all these equations. After the equations, we can write the expression for f. So here is the expression for f. Determine the domain and the range of f. Here, be careful about this arrow. So if you see arrow, it goes, it's endless, so it doesn't stop here. So it goes this way. Now if you see the arrow, it goes this way, so there's no end. Now the domain is the projection of the graph onto the x-axis. It touches the x-axis, it's okay, it's not empty. This point here. And always you take the projections from the from full points here, like not empty. So I'm not taking the projection of this, but I'm taking the projection of this. So as you see, the domain here will be f is minus infinity to infinity, because here we have this projection here. So it's we projected and we get the whole real line. So the whole real line is we can say the whole real line is this one here, the minus infinity to infinity, if you want to show. Now for the range, okay, for the range, we have to take the projection onto the y-axis. Okay, let's see. Yeah, you take all the time, you take from the non-empty points here. So you take the projection from the non-empty points, you take the projections. Okay, here, you don't take the projection here, but you can take the projections from here, but they give the same point here. So what is this set here? This set is the projection of the graph onto y-axis is making the range of f. So it will be, so it's closed here, so this is filled. There's no empty point here, so it will be from 0 to infinity. The range of f is from 0 to infinity, and 0 is included, this one here. Okay, determine the intervals where f is increasing, decreasing, or constant. So in this type of question, you always look at from left to right. Always look from left to right. So take a point here, like this is endless. Okay, so it's endless. Now take a point here and you move to the left, so it's going down. So when you go this way, the points are going down, so it's going down where from minus infinity up to 0. So this is, you say f is decreasing, it's down, so it's decreasing on minus infinity to 0. And the other one will be and then on this part, if you go this way, the points on the graph, okay, if you move on the graph, you will go up. So this is going up, and you say it's f is increasing on 0 to 2. Now the last thing comes to here. Starting from this point, okay, it's not on the graph, but you can start from the other points here. Now when you look at here, the graph is constant, and there's this arrow here, so it means it's not stopping here, it doesn't stop, so it goes endless. So from 2 to infinity, it's constant. And you can we generally use the open brackets here because at one point we don't discuss the behavior of the function at just one point. You cannot say at one point it's increasing or decreasing or constant, but we look at the behavior on an interval, so we take it open. So this is constant here. So we have three parts here. First part, second part, and here the third one. Increasing, decreasing, increasing, and constant. Determine the intervals on which f is 1 to 1. So 1 to 1 means like when you draw the lines here, like the horizontal lines, it will be only intersecting at once. Now, if you draw the lines here, I mean, if you draw the lines here, there you will see this here. So in this case, we write here, f is not 1 to 1. But it depends on what you choose here. This intervals, like if you choose this one here, minus infinity to infinity, then you can choose this choose this line, and you can see it's not 1 to 1. So it's not 1 to 1 on minus infinity to infinity. But if you take this one here, if you take only this part, so it means from minus infinity up to 0. What do you say for this part only? So it's 1 to 1. So f is 1 to 1 on minus infinity to 0. Look, okay, do you see the difference here? Do you see the difference? So if you include all real numbers, then your horizontal line will pass to the other side. But now, giving this, I mean, if we restrict the domain, then we do not extend the horizontal lines. Okay, now, the graph of f of x square root of x is stretched vertically by a factor 3. So f of x is equal to square root of x. It's stretched vertically by 3, then reflected across the x-axis, and finally shifted by 4 units down. Find the equation of the graph. So it's vertically stretched, then we get something, and then it's reflected across the x-axis. And we have something. Then after this, we have one more transformation. It's shifted by 4 units down. So we have another equation here. Now, this one here is changing, right? Now, how does it change? Now, let's remember this one here. When do we have stretching vertically? I mean, what does this mean? Which type of transformation gives stretching vertically by 3? So this is, if you remember, this will be y equal to f of x is changed to y equal to 3 times f of x. So it means, I mean, you can take this one as y equal to f of x. So now the transformation should be 3 times f of x, which is y equal to 3 times square root of x. Now, the reflection is, okay, what does it correspond to? If your function, which makes the reflection across the x-axis. So the reflection across the x-axis is making this one like y equal to minus square f of x. So if you remember it, like if you have y equal to f of x here, when you reflect it across the x-axis, so all these points come to here. So we have f of x becomes here, like if this is a, this becomes minus a. So all the y values to f of x's becomes minus f of x. So then there will be y equal to minus f of x here, right? So the x will not change, but y will change to negative. So this is the reflection through the x-axis. Now, this transformation is happening here, so it means 3 square root of x becomes minus 3 square root of x. So this becomes y equal to negative 3 square root of x. Now, what is the last one? The last one is shifting a function 4 units down. So it means y equal to f of x minus 4, if you remember. So it has to be, your function should be shifted 4 units down. So it has to be this function should be shifted 4 units down. So it has to be y equal to negative 3 square root of x minus 4. So the equation of the new graph will be, so you say here, the equation of the new graph is y equal to negative square root of 3x minus 4. List all the transformation in order to sketch the graph of y equal to f of minus x plus 1 from the graph of y equal to f of x, whose graph is given below. So we have y equal to f of x. For each transformation, sketch the corresponding graph in the same figure. Now, first I will say this from f of x. Okay, we can do some transformation. First, f of x becomes what? Okay, I will go with this one first, f of minus x. And this corresponds to what? This corresponds to reflecting across the y-axis. So here, x changes to minus x makes the reflection across the y-axis. And now it makes, okay, when you will do this job, you will get to here. So 2 will come to minus 2, and here minus 4, so it will be minus 4 here. Now you will have this one. Now this is the function, so it's better you say it's, we can do it like this. We can match it like 1, this is 1, so this is 1. Now 2, what is 2? And we have f of minus x, and it is multiplied with 3. Now this one becomes 3 times f of negative x, and this is stretching the function vertically by 3. Now, vertical by 3 means here, like if you have 2 in the y value, then you will get 3 times the y value. It will be 6. Now, 3 times this, the y value is same, then it's multiplied with 3, you see. Then it will be 3 times 2 makes 6. And if you take the half here, 3 times half will go up to here. Zero will be same. Now, if you have minus 2, it will go up to a negative 6 3 times, so it goes 3 times here. Now, this is the second one here. Now, the third one here is y equal to f of minus x. So I don't have space, so I will write it here. 3 times f of minus x becomes y equal to 3 times f of minus x plus 1. So you have the same function, but it's plus 1, so it means shift 1 unit up. So this is the third transformation. And if I do it, okay, I will make it with this one, with the green. So how do you lift this one up? So it will come to here, and this one will come to here, I guess, yeah. And this one will come up to here, and this will go up to here. So it will go 1 unit up. So that will be the green one. So these are corresponding figures for each transformation. Now calculate F composition G. It says, okay, this F composition G of X means F of G of X. And what is G of X? You can write here x squared plus 5. And what is this equal to? This f of x squared. So f of x, I mean, if you hesitate what to do, you can write f of x and write this one. And the key idea is this, instead of x, I write x squared plus 5. So here you do the same thing. So what do I write? I write x squared plus 5 instead of x. Then the rest is the same. It's minus 3. End up with x squared plus 2 square root x squared plus 2. You can do it here. So you write F composition G of X is this one. Now let Gx equal to x plus 1 and find a function f such that F composition Gx is x plus 2 over x squared plus 4x plus 5. Now in this question, we want to find a function such that f of Gx is equal to x plus 2 over x squared plus 4x plus 5. So here you can write this one here, x plus 2, and this f of x plus, sorry, this is x plus 1, this is gx is x plus 1, so we are looking for a function such that f of x plus 1 is equal to x plus 2 over x squared plus 4x plus 5. Now here to get this one, we use a mathematical trick. Okay, this is kind of a tricky question. We can set, okay, let x plus 1 is z. Then you can write here as f of z. Now the idea is to write everything in terms of z here. So it's, what is this in terms of z? So this is the idea. Now how can we convert this to a z here, a function of z? Now the idea here is using this conversion here, we can write here x is equal to z minus 1. Now we can replace x with z minus 1 here, and this will give you z minus 1 plus 2 and z minus 1 squared. So I'm employing this one here, plus 4 times z minus 1 plus 5. Now this will be f of z is equal to z plus 2. No, this is makes z plus 1, sorry, divided by z squared minus 2z plus 1 plus 4z minus 4 plus 5. Then when you calculate this one, you will get f as this. Z squared and minus 2z and 4z, it makes plus 2z. And 1 plus 1, and here this one will make plus 2. So we end up with this. You know, don't pay attention to this z here. So it's just the rule that for a function, you should be able to write the rule, and even you might use x, you might use z, that's no problem. So this gives the rule of f, and if you want to write it in terms of x again, well, you can change it with x, and the rule turns out to be f of x equal to x squared plus 2x plus 2. So this is the function we are looking for. So we found this function. This is how we can solve such problem. Now find a function g such that f of g is equal to x plus 2 over x squared plus 4x plus 5. Now f is given, so you can write here this f composition g of x is equal to f of gx, which is equal to, okay, it will be equal to this one for sure. But before that one, I want to use this one here. I mean, we have two things. To one, it will be equal to this. So this is the requirement of the question. And also you can write this one as, you know, here f of x is equal to 1 over x plus 5, x plus 1. And then f of gx should be equal to 1 over g of x plus 1. Now this f of g of x is also equal to, from this part, it's also equal to 1 over g of x plus 1. Now, are they same? They're same, right? So in this case, we match them. So we got this one here. 1 over, this one says it's 1 over g of x plus 2 plus 1 equal to x plus 2 over x squared plus 4x plus 5. Now, if you do this cross multiplication here, you can get x squared plus 4x plus 5 is equal to x plus 2 times g of x plus 2. And you can divide both sides with x plus 2, and you will end up with, this will be 1, sorry. You will end up with this. So then you can say this g of x is equal to x squared plus 4x plus 5 divided by x plus 2 minus 1. And it will give you, after doing this, I mean, this is the final answer. You can get it this way if it's an essay problem. But if you want to do some more job, you can combine it with 1. So you will end up with x squared plus 4x, it will be 3x minus 2, and this will be 3. Okay, there are both correct answers. For each of the following intervals, test if the function f of x equal to absolute value 2x minus 1 is 1 to 1 or not. Now here, the first thing you have to do is to check the 1 to 1 or not. Make the graph of them. Graph y equal to 2x minus 1. So when you make the graph of this, okay, find the y-intercept. So when x is equal to 0, it passes through 1. Let's say this is 1. And when y equal to 0, x equal to 1 or 2. I mean, you can check it here. So when y is equal to 0, then x is equal to 1 or 2. And here you can get some more values, but you know, if you think this way, in terms of the transformations, you can say here we have the absolute value of x becomes absolute value 2x. This is horizontal shrinking. And 2x minus 1, you know, I mean, we have to do it this way. X minus 1 and 2x minus 1. So 1 unit shift right. And now shrink by 2 horizontally. Shrink by 2 horizontally, it means like you had this one and then you move it to 1 unit right, so it was like that. Now it became like this. Then you shrink it like this. Now it makes a steep V, so it will make steeper. So you have something like this. Now we have the same issue, like this is the case here. We have. Now you have to check. This is for we did it for the graphing. After you graph it, then it's easy to tell at which, you know, on which interval it's 1 to 1 or 1 to 1. Now it says from -1 to infinity. So on this interval, it's definitely not 1 to 1. So not 1 to 1 because of the horizontal line test. Not 1 to 1. Now, if you do the test, only from 0 to infinity, so it means from 0 to infinity on this interval only, then we have the same issue. So it's not 1 to 1. So again, it's not one-to-one for this part. But if you do the test for 1/2 to infinity, if you take the test for 1/2 to infinity, so it means from starting from here and this part here, right? If you take this, only this part here, if you take this window, it will be, if you use the horizontal line test only on this interval from 1/2 to infinity, so it is one-to-one. So you say it's one-to-one on here. Now from -1 to infinity, now if you take this, now if you consider the domain as this one here, if you consider minus infinity up to 1/2, so it means you're taking this part and this is going, endless. Now if you use the horizontal line test only on this interval, the horizontal line test succeeds. Okay, so it tells it's one-to-one. So here it is one-to-one. I think, yeah, that's enough for this exercise. That's clear, I guess. Okay, determine the domain of f plus g, f minus g, and f times g and f over g. Now, let's remember this one. The domain of f plus g and domain of f minus g and the domain of f times g are same. And their domain of f intersection domain of g. And we can use the same thing for the others. Now, the first thing we have to do is like, what's the domain of f? So you'll look at here, this is a rational expression. This is like kasr, we don't want 0 here. So you have to say this, I accept all x values, but x squared minus 4 should not be equal to 0. So when you solve this one here, this x squared minus 4, you solve it, so you got x equal to 2 and minus 2. And then it means, not 0 means x should not be equal to 2 and x should not be equal to minus 2. So when you write this one, it means 2 and minus 2 is not accepted. Or you can say this one, all real numbers except minus 2 and 2. Okay, then domain of G is, okay, when you look at here, this part there's no problem, but with this part here, there's a problem. The problem is this square root cannot be equal to 0, it cannot be negative, so we have to have this one. So x plus 1 should be bigger than 0, and it cannot be equal to 0 because 0 makes the denominator 0, which makes the function undefined. So we are talking about all real numbers except, and they will satisfy this property. Like this, they will be bigger than minus 1. So you say, or we can say at the beginning, it's bigger than 1. So when you solve this one, it will be bigger than minus 1. So it will come to this set here, minus 1 to infinity. Now, when it comes to taking the intersection here, I would suggest making the real line minus 2 and 2 not included. Now minus 1. So here for this one, I do minus 1, not included, this one, and then the rest. So this part, right? So minus 1 up to infinity. Now for the intersection, I will check the mushtarak parts, the common parts. So minus 2 is not common, but here it goes up to here, it's common. And then this is not common, this is empty set, so it's empty, so you cannot take it. And their intersection will be now, the domain here will be their intersection, so it's the intersection of two sets, and it will be equal to minus 1 up to sorry, there's a mistake here. Okay, don't do such mistake. This is important. This is very important. You have to pay attention to the numbers here, their orders. Minus 1 is somewhere here. It will be like that. And then their intersection will be, okay, minus 1 is not included in this set, so I will not take it, and 2 is not included. So not the common points. So this point here, the common points are here from minus infinity up to 2, and then 2 to infinity. So the intersection of both domain is equal to minus 1 to minus 2 union 2 to infinity. So as a final answer, I can write here the domain of f plus g is the domain of f minus g. This is the domain of f times g, and which is equal to minus infinity to minus 1 to minus 2 union 2 to infinity. Sorry, this is 2. So this is 2, sorry. Now, what about the second part? The second part of the problem here is so here is the difference. The difference is the domain of here, we use this information here. The domain of f over g is equal to domain of f intersection domain of g, and we found that it's here, and minus, or we remove zeros of gx. So what does this mean, zeros of gx? So it means gx is equal to 0. So it means we set it equal to 0, we make it equal to 0. This we got, okay, this means when you multiply this with both sides with this, you will get x minus 3 equal to 0, and this x equal to 3. And the 3 doesn't make a problem here, so it's a solution. So then this means 0 of g is equal to only 3. So you write the set here minus 1 to 2 and 2 to infinity, and then you remove 3 from here. So it means remove 3 from the set. So how do you remove? I mean, you can, okay, make the set here, draw the set here, minus 1 up to 2 and 2 to infinity. Then you remove 3, so where's 3? So you find 3 here, find 3, and you make a hole there. So it means you remove this point, and now we have this domain here. And the domain will be minus 1 to 2, and union 2 to 3, and 3 to infinity. And this will be domain of f over g. Okay, let f of x is this, and find f inverse of x. I mean f inverse of x, yes. Okay, now it should be f, I guess, here. So this is how we do it. Now you can do it in different ways. I mean, one way is this. Okay, this is my way, and we teach it this way in class. Write this one as y equal to, then solve for x. So it means we write it this way, that you multiply both sides with 3, I mean x minus 3, and this is, you got 4x, sorry. It will be xy minus 3y equal to 4x. And then you collect all terms at one side, so it will be 4x minus xy. We have minus y here. And then you can, okay, the x is مشترك عامل here, common factors. So then you divide both sides with 4 minus y, and you will end up with this, x equal to negative 3y over 4 minus y. And you can multiply both sides with minus to get rid of this minus here. So you will end up with x equal to 3y over y minus 4. And then the second step is like change x to f inverse of x and y to x. So this will give you f of inverse of x is equal to 3x over x minus 4. This is how I do it, but some of you can do it this way. For example, some of you are doing it this way. Okay. Y equal to 4x minus x minus 3. Then replace xy. You say here this is x, and then this is 4y over y minus 3. Then solve for y. And you know, do the rest, like then change y equal to f inverse of x. This is also okay. I mean, this method is also okay. It comes to the same thing at the end. Okay, it's okay for a second method. Determine the domain of f. Here the domain of f is clearly it's equal to all the real numbers except x minus 3 should not be 0. Okay, if it is 0, then there's a problem, so we remove this case. So it means x should not be 3. So it means all the real numbers except 3. And you can write it as this way. Minus infinity to 3 and 3 to infinity. So it's like this. You remove 3 from the real line, so we have these two. Okay, now what is the domain of f inverse? The first thing is we have to find the F inverse here, and we did it as the first part here. So okay, let's remember this one. We found F inverse of X as it was something like y minus 4, and now this x minus 4, and it was like 3, I guess, 3x. This one we found it in the previous slide. So then I will use this one here. Okay, I will use this one. So domain of f is, I can say the domain here is this one, domain of f. So I will write it here. I want to keep the answers here. So I will say this is minus infinity to 3, union 3 to infinity. And there's a comma between them. Now let's come to the domain of f inverse. You know, the domain of f inverse is clearly, okay, the domain of f inverse is clearly, okay, what's happening here is x minus 4 cannot be 0. So it means x can be anything but 4. That means all real numbers except 4. So if you write it in the notation, like in this notation, the interval notation, it will be 4 removed. Okay, 4 removed from the all real line. So then we have this one as the domain. Okay, now the range of f. This is very interesting because we didn't solve any range problem before. I mean, directly we didn't do such problem, and most of the time it's hard to find the range. Like, it's not very hard, but generally not straightforward. So, but here to find the range of f, okay, in range of f, we use a shortcut information. Range of f is equal to domain of f inverse. So, and we have it here. We can directly say it's minus infinity to 4, and then union 4 to infinity. Now for E, we have this shortcut. Range of f inverse is, we know it's the domain of f, and which is equal to minus infinity to 3 union 3 to infinity. So these are the shortcuts here. These equalities are the shortcuts for the range. Show that the following functions are inverses of each other. Now, in order to show the functions, two functions are inverses of each other, so we have to show this first. Okay, you have to show this, and also show g of f of x is equal to x. Now, let's start from this one, and let's do it later. Now, to show means like here, you will start calculating this, and you will end up with x here. So if you end up with x, then you will say, okay, it has been shown. Now, let's do it. The f of x, okay, it will take some space, so I will try to write it smaller. This is f of g of x, so g of x is this one here. So now it comes to this one. Now here instead of x we see the whole term here, the x minus 1 squared over x squared. Now x changes to this one, so we have to do the same thing here. So then it will give us 1 over square root of x minus 1 squared divided by x squared, this one. Now let's look at this square root for a minute. Okay, square root of x minus 1 squared divided by x squared, so you can distribute square root to the numerator and the denominator, and we know this one will be equal to the absolute value of x minus 1. That will be equal to the absolute value of x. Now we have to know, I mean, what is this? Like, this is plus or minus here, and this is plus or minus. So is it negative or positive? So what tells us it's positive or negative? Now here, the important thing here, I mean, do we have such condition on x? Yes, like when you put here x, the x is the input, x is the input of g. Now, if x is the input of g, then g accepts these x values. So our condition on x is, since the input, this x is the input, first the input of g, then we have this condition. So we can do this composition job if x is accepted by g, and this is the condition for x. Now, if this is the condition, then first x is positive, right? So because of this bigger than sign here, so this will be the absolute value of x will be x. Now, the second thing here is, look at here, this one says x is bigger than or equal to 1. And what does this mean? This means x minus 1 is less than or equal to 0. So it means x minus 1 is negative or 0. So if it is negative or 0, then the absolute value of x minus 1 should be minus x minus 1, because it is negative inside, negative or 0, so it's negative. So we treat it as it's negative. So then you multiply with negative. So you have negative x minus 1, and this will give us, you can do like minus x plus 1, and you can write it as 1 minus x divided by x. So here we have this one, 1 over, this one is, we found it, it's 1 minus x over x. There's this plus. Now 1 over, so when you do this job here, 1 minus x over x plus 1, you know, we did it several times, and we use some assignments like that. This is 1 minus x plus x over x, so we end up with this, they cancel out, so we got 1 over x. So this has to be 1 over x. And okay, here these are the side calculations, and this part is the square root part is important. This just you know, we remembered how to deal with the absolute value if x has some condition, so we figured it out, and then we got back to our goal. Okay, what is this calculation? This is equal to, like, when you flip it over, so you get x. Now let's look at, okay, we have shown this is equal to the x. Now we will show the other way, that g of f x is equal to x. Now let's start. This is g of f of x is 1 over square root of x plus 1 And as you see here, instead of x, we see instead of x, we have seen this one, and we will see this one here. And it will be, instead of x, we write 1 over 1 plus square root of x minus 1 squared divided by 1 over 1 plus square root of x squared. And then, okay, let's do this one here, 1 over 1 plus square root of x. This one, okay, I will do it separately. Like, if you're good at it, like, you can directly write it, but if you have, if you have to do it, do it in a separate place and make it tediously. So we multiply them so that we get this one. And you combine them this way. And this will become minus square root of x over 1 plus square root of x. When you distribute, you will have this one. Now, I will write this one now as here, minus square root of x divided by 1 plus square root of x squared divided by 1 over 1 plus square root of x squared. Now this is giving you a fraction here. The numerator is giving you a fraction, and the denominator is giving you another fraction. And then it gives us negative squared x squared divided by 1 plus square root of x squared. Now I wrote this one here, and then I write this one as the reciprocal. So I flip this one, and I change this 1 plus squared divided by 1 squared. So I write this one, I flip, I take the square of all, and then there will be this cancellation, and we will have this minus square root of x squared divided by 1 squared, and which is here, this one will be plus, and this one will be x, so we end up with x here. So we are done. We have shown this F composition G and G composition F is equal to x, so they're inverses of each other. It's done. This is another exercise for showing the functions are inverses of each other. Show that this function f of x and g of x are inverses of each other. Again, we want to show F composition g of x is equal to x. First, we have to show this one, and then show g of f of x is equal to x. Now, let's do this one first. So we basically calculate this one. Now, this will be f of g of x. What is g of x? It's this. Now, instead of x, we see here the whole thing as the input. So we have to put, instead of x, we have to put this one. Now, it gives us 3 times cube root of x plus 5 cubed divided by 27 minus 5, and this makes 3 times the cube root of x plus 5 cubed, and then the cube root of 27 minus 5. And this is odd power in the odd root, and this is odd power in 3, and then you can directly cancel them. You can get 3 times x plus 5 over the cube root of 27 is 3, because we have this cube root of 3 cubed, which is 27, and then we have this. It will be equal to 3 minus 5, so we end up with this x plus 5 minus 5. This is equal to x. So we have shown this calculation. This one is equal to x. Now we are done. Now when it comes to the other question, the other part, I think I can fit it here maybe. Okay, this is another part now. G composition f of x is equal to g of f of x, which is equal to g of f of x is what? This is 3 cube root of x minus 5, and this will become x 3 cube root of x minus 5 plus 5 cubed divided by 27. Now there you will see the cancellation, and this is 3 cubed. Well, this is 3 cube root of x cubed, and this will give you 3 cubed times cube root of x 27. Now this is 27 and 27, they cancel out, and we will have this cube root and cube, and you will have cancellation here, and you will get x. So we are done with this. So we have shown this function and g are the inverses of each other. Now let's look at these graphs and calculate these values. Let's evaluate them. F of 1. So look at the graph of f of x, and now here we want to find f of 1. Now first you take the x equal to 1. So this is x equal to 1 is here 1. Its place is here. Now you want to find, okay, there you see it's corresponding to 2 points or 3 points on the graph, this point, and we have x equal to 1 is corresponding to 3 graphs here, 1, 2, 3. But which one is on the graph? So this here, the empty circles here, you see, x equal to 1 is, the graph, the point is does not belong to the graph. So we have to take the full circle here. So when x equal to 1, here if you see this one, it will be on the graph. This is on the graph. So then this is this is 1 and corresponds to 2. So if it is on the graph, then the 1 is, so if this is 1 and the other number turns out to be f of 1. So f of 1 is equal to 2. This one here is all the time. If this is x is 1, and then f of 1 is y. You take an xy point, then for this reason we say it's y equal to x function here. Y equal to x means, like, if you take an x here, the corresponding y is equal to here on this line, especially it will be equal to f of x. Now for f of 2, so you find 2, x equal to 2, it's here, and you find the corresponding point on the graph, and this is on the graph because it's not empty. So then what is corresponding y value? It's 1. So you say the f of 2 is 1. Or you can say this one here is always 1, 2 means here on the graph of f, 1, f of 1. So f of 1 is equal to 2. Now f of 0, what is f of 0? Now look at here, let's look at here. So f of 0, we check x equal to 0, x equal to 0, and does it intersect with the graph? It intersects at an empty point, so this is not on the graph. So what does this mean? If it is not on the graph and this x equal to 0 is not intersecting with the line or with the graph, so it means there is no corresponding point on the graph. So here f of 0, no f of 0 here, right? So 0 is not, so 0, x equals to 0 does not correspond to a y value on the graph of f of x. So in this case, we say what we say here is f of 0 is undefined. So what is f of 4? F of 4 here is, it means f of 4. So we have to find f of 4 first. What is f of 4? So f of 4 is, okay, we get the point corresponding to 4 on the graph, and it's 4, 1. So it means this one is f of 4. So f of 4 is 4. Then again, we look at f of 4, which is 4 again. So as you see here, this is 4 we got, and now we get f of 4 is equal to what? And again, with the same logic here, we got, okay, what do we get? F of 4 is equal to, no, hold on. So I made a mistake here, okay. F of 4 is not 4, f of 4 is 1. Now, as you see here, f of 4, take the point here, it will be equal to 4, 1. So this is f of 4. So f of 4 is definitely 1. So f of 4 is what? F of 4 is 1, we said. So what is f of 1? So again, when you go to 1 here, the corresponding point is on the graph is 2 here. So you got 1, 2 on the graph. So it means 1, this is f of 1, which is 2. So this turns out to be 2. So this will be equal to 2. Now f composition g of 2 f composition g of 2 means f composition g of 2. So g of 2 is what? So we look at g of 2. Where is 2? You take the point on the graph, so it will be corresponding to 2. So g of 2 is equal to 2. So what is f of 2? And f of 2, we know it's like f of 2 is corresponding to 1 here. So we say this is 1. What is g inverse of 3? So g inverse 3 is like this time you're taking 3 from the y. So you are trying to find the x corresponding to, okay, now you're trying to find this. if G inverse is 3 equal to, if we say this is x, then Gx should be equal to 3. So indeed, you are trying to find the x value corresponding to 3 on the graph of G. So look at here, the y, okay, you find x, y is equal to 3, then you find the x. So as you see, this is on the graph of G of x, and the corresponding x value is 3. So then you can say we have G of 3 is equal to 3. So G inverse of 3 is equal to 3. So for the inverse function, you go from the y-axis, you start from the y and go x. But in normal conditions, we go all the time this. We find the y value, we give the x value, find the y value. But in the inverse functions, we always look at the y value and then find the x value. Now, what is f composition G inverse of 3? We know from the previous part, this is f G inverse of 3 is 3. Now we have to check 3. What is 3? Now there are two corresponding points for 3, but this one is full and this one is empty, so we don't take this one. And the point on the graph is this one here. So what is this? This is 3, 0. So this is 3 is x, and then what is this? This is f of 3 then. So what is f of 3? It's 0. Now it says find a such that GA is equal to 0. Now, so it's asking again, the logic is this one here. It's giving you the y value and asking you the x value. So it's 0 is here, and now 0 is on the y level, it's this. So you try to find you find the point on the on the graph of f. No, on the graph of G, sorry. So you find this one, and what is this corresponding to? Like, what is this x value? Or we say, what is this a value here? This a value is negative 2 point. It's about, like, we can say it's about negative 2.5, something like this. So a is something like that, you know. Yeah, it will be a comma 0. Right, and we want GA equal to 0. Yes, this is on the graph. So on the graph of G of A, this is on the graph of G, so it will correspond to GA. So A should be approximately negative 2.5. Now, if f of GA is, find f composition G of A, if f of x is equal to 2 over x and GA is equal to 2. Now you can write this way. So f composition GA is f G of A, and G of A is equal to 2 here. This is given. This is given. Now f of 2 is what? If you put 3 here, you have to put 3 here. So it will be 2 over 2, which is 1. Now let's let f of x is this for x bigger than 1. So if it gives you restricted domain, you have to pay attention to this. So x is bigger than 1. This is important because in finding the inverse, you have to pay attention to this. Find f in this domain, like on this domain means in here. Okay. Now we use the usual procedure here. Step 1. Write y equal to x squared minus 2x and solve it for x. So let's do it. So it might be a little hard to solve this one. Okay, how can you solve it for x? There are two ways. First, okay, first thing is, if you notice, like if you add 1 to both sides, you get this one, and this is x minus 1 squared. It will be y plus 1, and from here you get x minus 1 is equal to plus or minus square root y plus 1. The question here is, okay, from here we get two values here. It's 1 plus square root y plus 1 or minus here. So then you have to choose one of them. Otherwise, this will not be a function. So 1x cannot go to 2 y values, or 1 y value cannot go to 2 x values if there's an inverse. Now, here you have to pay attention to this again. How it says x is bigger than 1. So bigger than 1 means you have to choose. We have to choose x is bigger than 1 is 1 plus square root y plus 1. It's not minus, right? So if it is minus, then it will be less. So we choose this one. And then you can say, I choose this one because x is bigger than 1. Okay, now I found it. And step 2, change x to f inverse of x and y to x. So I will say f inverse of x is equal to 1 plus square root of x plus 1. Now it gives the answer is the square root. The f inverse is 1 plus square root of x plus 1. Now I want to concentrate on solving this part here again. If you don't know the trick here, then you can do it with the quadratic form. Okay, I will write this one. Now this one, you can do it by quadratic formula. You can do it this way, x squared minus 2x minus y. So how can you use the quadratic formula? Quadratic formula. Okay, then we have x equal to, what is a here? So in a is 1, b is minus 2, and c is minus y. Okay, we keep this in mind. So this is minus b, which is minus minus 2, plus minus square root b squared. It will be b squared 4 minus 4 times 1 times minus y divided by here. Okay, it's this. Okay, then this will be 2 times a, 2 times 1. So it will be 2 plus minus square root 4 plus 4y divided by 2. And then you will end up with this x is equal to 2 plus minus 2 times square root 1 plus y divided by 2. And after the cancellation of 2's here, so you got 1 plus minus square root y plus 1. Now then you will go to step 2. Okay. Now you can use the quadratic formula in this way also, because you will get to the same thing. Okay, I think now maybe some of you will ask this one here. How does it become this one? You can write it this way, like 4 times 1 plus y then this is مشترك عامل 4. You can separate them, and it comes to here. So this will be 2, and this will be squared 1 plus y. Anyway, at the end, you will get this one. Even you use the quadratic formula, and then you can do the rest this way. Like here, you will say x is bigger than 1, so x should be equal to 1 plus squared y plus 1. And then you do the step 2 here.